this is a perfect example of dual use. Eckert Wimmer. Eckert Wimmer announced in 2001 that his lab had been able to assemble synthetic poliovirus, right, by piecing together the viral genome based on its sequence that was publicly available in the internet. Most people who study polio think there was no valid reason to do this, that this was just a stunt, right? It didn't really teach us anything except that it was possible to synthetically create viruses that might otherwise be difficult to get. Polio is not difficult to get, but it taught us something important. It taught us that you could actually do this. And at the time, the US and other countries were not monitoring the individuals who were acquiring these, because you can order these from a variety of different scientific companies that will make sequences for you. You just send them the sequence and they send you the DNA or the RNA, whatever you ask for, and you can just assemble it yourself. Now we monitor that pretty carefully. If people are looking for sequences that are associated with certain viruses, then we hopefully will be able to find that. But still, it taught something that we didn't otherwise know. We also have the issue of laboratory safety when we're working with these agents. And so this is an example from 2005 where 3 Boston University researchers became ill after being exposed to tularemia. Nancy, you know about this case, don't you?
I know the kid who accidentally sent the wrong strain out.
Right. So would you tell us about what happened here?
So there's a vaccine strain of Francisella tularensis and many, as I'm sure you all know, many virulent strains. And so researchers in BU were beginning a program, and so they wrote to a colleague in Arizona and asked for the vaccine strain because they wanted to work at BSL-2, you know, and not in biocontainment, you know, with outbreak, you know, sort of hoods and so forth and special air. They wanted to work at BSL-2. So the strain came, and they started to do all their experiments. And of course, aerosols are produced just by doing experiments, and there were in fact several infections. And tularemia is treatable, you know, so they were quickly able to figure out. No one died. Luckily, no one died, but it was an accident carried out by the person who sent the strain out. The person who sent the strain out just got the two tubes mixed up and sent the wrong one. So it was pretty serious.
Right, and there were 2 things from the Boston side about that, or actually more than 2, but 2 at least from the Boston side. One is that there actually were people developing symptoms of tularemia, and they didn't report it to anyone because they didn't stop to think that that might have been tularemia because they were working with the vaccine strain. And the other thing they didn't do, and this relates to a different type of thing, but it happened in a California university that early on wanted to work with Bacillus anthracis. And so, but you couldn't ship Bacillus anthracis viable organisms around. But there was a company in Alabama that would make for you an irradiated culture of Bacillus anthracis. And that was legal to send around because it was inactivated. So the company irradiated the Bacillus anthracis and sent it to the researchers in California through the mail, by the way, no special restrictions required, no special handling restrictions required. They wanted to make antibodies to the spores and to some of the bacilli, so they took that preparation and they injected it intraperitoneally into some mice. They were trying to make antibodies, and all 10 of the mice died. So they thought, wow, that's pretty interesting. We wonder why that happened. So they just disposed of the mice like you normally dispose of dead mice. You know, you feed them to your cat or whatever. But anyway, they disposed of the mice, and then they repeated the experiment, and all 10 of the mice died. And then they cultured it out, and they cultured out pure Bacillus anthracis. Because the company that sent this out, even though they certified it as irradiated and sterile, didn't do it. They sent out a viable organism, a viable strain that these investigators received and treated as if it were safe. Now, we have a rule of thumb in our laboratory, by the way, is that you always validate your starting material and never assume that it is what you ordered until you prove it. And so I think that's probably a good way to approach things.